OK，
耶！陈平，你要不要坐我旁边？因为你等一下脸露一下。可是你在他之前呢？干嘛？哦，之后。好。
我要先 stop sharing， 对不对
？OK。Alright。洪老师。
Yes. Okay. We're live.
We're live now. We are live now. Hello.
Yay! Hello.
Hello, everyone. Here's the tea drink. Hello. Yeah. Yeah. I mean, we are having a tea party. Jeff is also here. Jeff from ENS, the front-end engineer. Chang-Wu is with us, and Hsiao-Wei, and Ping Chen, and Cecilia, and really happy to see everyone here. Welcome to Taipei Ethereum Meetup. I'm your moderator, like the host. I'm Yaxing. Very happy to see everyone. So before I invite all the speakers to talk a little bit and discuss a few things, I'd like to share maybe a little intro about Taipei Ethereum Group. So today is not the first time we are doing this. We have done this many times before. We had Mikara from Toronto, Canada. We had Cayman from Texas, USA, tech lead of Flowstar. We have Perpetual Protocol founder Yigan Wenfeng. We had Dio CTO Dominic Lest from Berlin, Germany. So we've done many times, and we're so excited that we are having very special guests today with us. So we have Vitalik from somewhere in the world, and Dr. Chang-Wu is in a university because he had a seminar this afternoon. So Hsiao-Wei is also with us, and we're at this co-working space, and Ping Chen is also with us. And my colleague, Peter Lai, is also with us today. So Taipei Ethereum Meetup Group is a local developer-focused group in Taiwan. The group started in April 2016 with less than a dozen people, and the goal, really our goal is to bring Ethereum developers together to share knowledge and educate them. Maybe those who are not so familiar with Ethereum, and to introduce them to have host meetups and workshops to guide them into the Ethereum world. I'm really excited that this year we are going to have another Crosslink. So Crosslink last year was a big success. It was organized by Fini Yang and Hsiao-Wei and a lot of core members in the group. So this year we're going to have another Crosslink event. So the second edition of Crosslink in November, 28th of November on Saturday. So it's going to be an intensive, a whole day of very interesting hands-on workshops and conference events. So I invite you to follow our Twitter accounts and follow our Facebook and our meetup.com group page so that you can be updated and really know what's been happening in space. So today we have very special guests. So I'm gonna invite Dr. Chang-Wu Chen to first talk a little bit about what's been on his schedule this year. So before I invite him to join the stage, I'd like to give a little introduction. So Chang-Wu is the head of I'm Token Labs. It's the new team that he recently joined. So I heard from him that he started this new office in Taipei City just last week, and he's starting to do a lot of recruiting work. So recruiting in the backend engineers and blockchain engineers. And today he's going to talk to us about what crypto ecosystems are looking for and in terms of scalability. So please join me in welcoming Chang-Wu.
Hi. So let me share my screen. Okay. Could you see my screen now?
Yes.
Yes.
Okay. So thanks for the introduction and Yaxin. I'm happy to attend this meetup and the long time no see for Vitalik. Okay, so today I'm gonna talk about what crypto ecosystem looks like. This just my personal thoughts in the past 2 years. So a brief introduction about me. I'm Chang-Wu, and I currently just joined I'm Token as a chief scientist, and we will lead I'm Token Labs in Taipei. And also I'm currently teaching Ethereum courses at National Zhengzhou University. Yep. So at the beginning, I want to try to explain from the perspective as a builder. So for applications that we can see a lot of application has already built in Ethereum ecosystem. Especially we can see the rise of DeFi, like Uniswap, which has a built-in AMM protocol, and also we could have which is a lending protocol, and we can see a lot of DeFi application just coming around this months. However, I mean, we can see a lot of a huge success of this DeFi dApp. However, the transaction fee gets too high, such that lots of people cannot just use the token transfer or general dApp. So this might be another problem. So I could see lots of DeFi team currently they are looking for some alternative solution which they can rely on to reduce the transaction fee. And the second, I could see a lot of non-fungible token application is getting more popular, like the marketplace on OpenSea. So in the past 2 years, I can see lots of dApp has huge success. However, the transaction fee is too high. So I think if we want these dApps going successful, then we need to have a scalable ecosystem. And from the user experience, we can see in the past years, lots of people just build a smart contract wallet. For example, like Argent or Unit login. And you can see lots of nice features are built in this kind of smart contract wallet, like meta transaction, which provides user the ability they don't need to buy the ETH to start using their app. And also, this kind of smart contract has multi-signature ability. So people could secure their assets into the smart contract and protect by the multi-signature. However, we can also see some of wallet made by, or I mean, secured by threshold signature scheme. But it's the difference between the smart contract wallet with the threshold signature wallet is using threshold signature scheme. You can have you only have a private key, so you can do native token transfer without the smart contract. And with the threshold signature scheme, we can see some of the stable coin can apply on this scheme to do some decentralized cross-chain transfer. So for example, like TBDC, it's bridge Bitcoin, it's bridge Bitcoin and Ethereum, and it rely on threshold signature scheme to act as a custodian to secure the assets. So this is a kind of a new technique which can allow us to develop and build some new applications. So we can, I think we can see a lot of potential. This kind of scheme will be applied in the future. And last, for scalability, we can see, I think the phase 0 will be done very soon on Ethereum 2, because we can see a lot of testnet has already running through the past months. And also we could see some of the layer 2 solution will be coming. So for example, like Plasma, which is operated by Omesco, they are they are planning to using Plasma as the for USDT transfer. And also we can see ZK rollup and the OVN will be coming. So but the difference is now, I think the layer 2 solution for now is kind of a war. So we do not know which one or which skin will be the winner for the last. But for ZK rollup, it's more, currently it's more focused on just token transfer. But for OVN, it's more general computation. So it might be more potential for other EVM compatible computation. Okay, so yeah, so I would like to see a lot of application building on top of that. And I also want to recommend Django. Django has a very good team for cryptography, and they manage a very good Telegram group for cryptography research. It might be a good resource if you're interested in ZK knowledge proof or threshold signature scheme. And at the last, because it's only 5 minutes, so I want to say we are hiring at the Token Labs in Taipei. If you are interested, please just DM me or email me. Thanks.
Yeah, Chang-Wu, can you go back to the slide, like previous slide?
Mm-hmm.
Yeah, so I wanted to ask if Vitalik or anyone on the stage have any thoughts or questions you would like to ask to Chang-Wu.
I guess like what is I mean, I don't know if you can talk about this, but like what is IM Token's approach going to be in terms of like working with all of these layer 2s and other things?
Yeah, this is an interesting question. So yeah, because I just joined in IM Token, and I know they has their priority so far. So yeah, but definitely I think we will apply some layer 2 solution on our wallet, because I think our wallet is a pretty fundamental tool to allow the user to use all of the dApp in Ethereum ecosystem. So I think it might, yeah, it will not be known, but yeah, if we could recruit people fast, then we can build fast. Yeah, and do you have any suggestion, Vitalik?
I think integrating the layer 2s is definitely important. I wrote that post in that presentation about how I think, like, for security, I mean, I think we need the wallets to kind of support all the layer 2s and ideally have some standardization so that, like, ideally the layer 2s do a bit of work, and then they can just plug into all the wallets, and the wallets do some work. They can plug into all the layer 2s, which would be nice. Again, I just hope that this happens in a way that's like as user-friendly and nice and secure as possible, I guess.
Right. User experience is another problem. Yeah, true.
Yeah.
Thanks very much, Chang-Wu. So next up, I'm going to invite Hsiao-Wei Wang. Let me switch the presentation slides very quickly. Can you help me check if the slides are showing? If the slides are showing properly?
Wait.
So just give me a little. Just wanted to make sure that the Google slides are showing. Yeah. Okay. 这边吗
present.
okay 吗 Okay, just give me a little. So CC is my.
It's not showing yet.
Okay, so how do I?
You have to go into the call.
Okay.
And click present. And present the tab.
Okay.
boost the slide.
There you go. Okay, here we go. And then present. Okay, I'm gonna invite Hsiao-Wei Wang. She's the Eth 2.0 researcher at Ethereum Foundation. So take it away. Hello, can you hear me?
Yes.
Okay, check. Hi, I'm Hsiao-Wei, and I'm going to give a 5 minutes highlight about some recent Eth 2.0 upgrade progress. So first, let's talk about the phase 0. So we are very close to have the 1.0 core stake release. There's already a candidate branch on the repository, and this year the clients were more focused on the testnet implementations. So that, for example, we have like more than 6 cross-client public testnets on the Eth 1 Garlic testnet this year. And meanwhile, the client teams are keeping working on the testing and getting reviews and audits of their softwares. And there's some interesting groups like Become Fuzzing group to use fuzzing to generate the test automatically. And also, Ethereum Foundation has raised the public attack nets so that you can, the white hat hackers, they can actually try to dominate this small attack nets and get the bounty rewards from it. Second is the Madasha, the long-term public testnet. Today I checked, we have like more than 70,000 active validators so far. This testnet was launched in August. And as you can see from the participation rate graph that here in like the mid-August that we had a consensus error between the client teams. It was the cause root was that the rough time bug issue that in present clients, and since the prison they dominate the testnet very largely, like I think more than 50, maybe 70 clients, maybe more than 70 validators were using prison, so that it caused a very serious finality crisis for a long period. But after that, with many fixed patches, finally the Medasha came back to life. So it was actually a very helpful and useful stress test for all of us. And it also shows it's important to keep the client diversity up. And then we are talking about the phase 1 plus progress. So I think 3 most important progress this year is that the first is, of course, the phase 1 spec iterations. We have at least 2 clients are working on some POCs. And the second one is that there was a kind of a roadmap amendment this year. I think it was initiated by Proto in March, that we can try to prioritize the phase 1 integration into the phase 2 as soon as possible, so that the Eth 1 into to merging Eth 1 into Eth 2 as soon as possible, so that the Eth 1 mainnet will become a shard of Eth 2. And there's a very interesting demo by Michael and Guillaume. This is the link, and I can share the slides later And the third one, I think some guy here knows it the most, that there were many new commitment schemes this year. The breakthrough this year, that it will provide us to use more efficient ways to accumulate and validate the state. Yep. Okay. Hi. Okay. Oh, we're back. So then what's happening now is the Zincan testnet. So today is actually the due date of the Genesis deposit, but it still have chance to become a validator and of Zincan. Zincan is another dress rehearsal testnet. So to prepare for the mainnet launch. The Genesis time will be next Monday. So if you are interested in that, go to the Launchpad to participate the testnet. What's next here? Okay, so this is the GitHub project board that shows some work in progress tests for preparing the phase 0 launch. So mainly it's just test. We are keeping testing, and we're also refining the infrastructures and tools like the keystone tools and other like for the hardware wallet support, also the audit. So yeah, I can follow this link to see the transparent progress of what's happening in these two. Okay, the final page here is, so this is my colleague, Danny Ryan, the captain Eth 2.0. So, so I think it's important that Eth 2.0 is a project that built on the existing network, the existing blockchain. So we really need and really thanks for the community support and also the client teams that other research teams that we keep working for years. And this is a very good chance if you want to participating and if you really care about the long life of Eth 2.0, that please join the testnet and give us some feedback. Yeah, that's all. Thank you.
Thanks very much, Hsiao-Wei. Stop sharing this presentation.
Oh, no, go back to here.
All right. Stop presenting. Yeah, so thanks very much, Hsiao-Wei. So the ENS front-end engineer, Jeff, he has a few questions for Hsiao-Wei right now. Maybe just one. Okay, you're gonna come over and yeah. Yeah. Okay, great. And then talk to the microphone.
Okay, so Hsiao-Wei, so I wanted to know, since recently the rise of layer 2 solutions have been kind of in the Twitter sphere and generally in the crypto space, how do you think that affects the roadmap of Eth 2, if any?
Rollups.
Exactly, rollups, plasma.
Yeah, I know some guy here knows it the most. But for me, I can give a quick answer is that so the layer 2 technologies is never an enemy or to the core spec and development. It's like one. It's not 1 plus 1. It's like 1 multiply 1 unmultiply like that. So if the rollup technology is going better than we expect right now, then I think it will be better. It is better than we expected years ago. With the layer 2 technologies,
if it already fixed the most transaction overhead of the current use cases, then we can simplify the to core specs very largely. Like we can focus more about the data availability technology instead of put more resource in the state executions that may happen in phase 2. Yeah. Does anyone here want to answer it?
Does anyone here want to answer?
No, I think that answer is definitely very correct. And I think you've already covered the important things. Basically, that I think the existing sharding roadmap already kind of plays very well with layer 2 protocols. So like even the fact that, for example, we have sharding of data coming in phase 1, and that creates just a huge amount of data space that rollups can use to fit transactions, I think will be amazing for rollups. So when phase 1 starts to come around. So I see layer 2 development and ETH 2 development as being kind of separate strands for now. They'll come together at some point in maybe 1 to 2 years, but they're definitely cooperating with each other. They're not competing.
Okay, thanks.
Thanks very much, Xiao-Wei. So I'm gonna invite our next speaker. Thanks very much. All right, so I'm gonna invite Tenping to sit next to me. Yeah, because this is the place where we get the audio. So I'm very excited to have Tenping with us today. So he's the founder and CEO of Palace, and also the founder of Hakka Finance, which is the popular DeFi project in the world. So he's going to talk about gas repricing, right?
Yes.
Yes. So I'm gonna switch the presentation slides right now. Present now. This one. Okay. Down. Go on. Okay, present. Okay, here we go. Okay. Okay, go ahead and start.
Okay. So today I'm going to briefly introduce the new EIP 2929 and my own opinion as a dev developer. And I'm Ping Chen, the founder of Hakka Finance and the CEO of Palace. And in brief, EIP 2929 is a proposal of raising state access opcode price. And that's quite a bit. Like for loading a word, it will be raised from 8 to 2100. And for the code family, it will be like, I'm not sure it's 40 or 60, but it will be raised to 2.6K, and that's a lot. And the reason is mainly because first, we want to rebalance the gas cost and the computation cost of several opcodes. And you may refer to the previous EIP 1884 for the reason, because people are finding out that loading storage from hard disk is quite time consuming recently. And the second reason is because we would like to prepare for a stateless client for ETH 1, because that would be more easier to integrate that into ETH 2 as a shard. And so for your reference, currently the validator on ETH 1, we will call them miners, and we assume all of them have the full state of the blockchain, including the account balance and code and storage. So when you want to broadcast a transaction, it's much easier. You just send it. But if you want to make like client to validate transactions, and since they only have block header, we need to attach the state proof when we want to broadcast transaction, and verifying that would be quite time consuming. So we want to raise the gas price of state access opcodes. And since that is a breaking change, so we assume that quite makes some unflavored side effect. And for example, when we raise the gas cost of those opcode and we have the block gas limit remain, then we might have lower TPS, lower bandwidth. And also that kind of breaking change might break some existing smart contract on the blockchain. And there are some mitigations. For example, we can make code chunking or code Merkleize to sort of reduce the loading cost. And also we might have a different pricing model from charge per opcode to charge per witness size. And also we might just stop using proxy contracts, which will have extra delegate code. But then we have new concerns like if we have new pricing model, then we might have some inequality between transaction costs. And also if we stop using proxy contract, there might be some issues of the state size. Because currently a proxy pattern are used to make clones of some identical smart contracts. For example, NoSeSafe wallet is using proxy instead of deploying the master copy every time. And we can take Uniswap as an example. In Uniswap V1, they are using proxy, so the code size per each pair is quite low, it's 46 bytes. But since Uniswap V2 is no longer using proxies, then they need much more on-chain state to store exactly the same logic here and there. And since we are raising the gas of code family, including delegate code, that might encourage people to use that might discourage people from using proxy contract and might cause unfavored side effect of on-chain state explosion. So me as a dev developer are quite worried because if you remember the experience of previous hard fork and the EIP 1884, I would say that's quite messy at that moment. And I personally coded another form of the speaker and listener fault equivalence, which is though our core dev team are pretty open-minded and willing to listen to people's comments, but if they are not asking the right stakeholders, then they might still make some bad decisions eventually. So yeah, we are still, this EIP is still in its early stage, so hope we can do things better this time. Thank you.
Thanks very much, Ping. So I'm gonna ask you to stay. And while I switch this, is it stop sharing now? Is it stop sharing now?
Yes.
The presentation slides? Yeah. So I wonder if like Vitalik or Chang-Wu have any comments or thoughts on this particular topic?
I mean, I guess I feel like we've already been kind of more careful this time around than we were with 1884. So, like for example, one change that 2929 is adding is it's saying only the first time you access something it costs a lot of gas, and the second time the cost goes back down to 100. So it's actually like it turns out there's actually like on average, if you include the pluses and the minuses, it only makes execution like I think it was 2% less gas efficient, and there's some cases like ERC20 transfers, for example, that actually become more efficient. And then there's EIP 2930, which tries to mitigate the breakages, which could be added at the same time or later. So there's definitely things that we have taken in mind, that there's definitely, and I know like Martin Svenda has done a lot of measurements to try to see like what exactly the consequences are going to be. But we're definitely interested in ways to make it as not disruptive as possible. And then I do think that in the long term we are going to do some of the kind of mitigations that we talked about, like switching to charging kind of per byte and so forth. I think the thing that we have to trade off against, I guess, is that like in a lot of kind of Eth 1 decisions, there's this trade-off where you can either choose to not interfere with existing applications, or you can choose to let dumb decisions that we made in 2015 make it the Ethereum a bad protocol forever. And like you do have to kind of like you can't you do have to kind of trade those two off with each other. So I think like the thing that's important is both obviously doing the research and making sure that we can do the changes that we need to do and as not disruptively as possible, and figuring out different ways to do that, but also at the same time like realizing that there are some changes that are going to happen, and like basically being pragmatic about the best way to do them. So like, and I definitely think this is designing these EIPs is definitely kind of far from easy, and like even the previous one, like the one that we did in 2016, and only really succeeded because it was very easy because there was an attack on the blockchain, and so the blockchain would just break if we didn't do anything. But here, like as time goes on, it definitely and it gets harder. So I actually think that if we can do those things now, then in the long term, the amount of disruption could be less. And we'll see.
So I want to ask one last question to Ping Chen before I invite Vitalik to do his presentation. So the last question is, I heard that you have some great products coming up, or you have already rolled out a few interesting Hakka Finance products. Would you mind like tell us a little bit?
We have already shipped several products, including the DEX and insurance, and there will be some synthetic derivatives upcoming soon. And I would like to emphasize that we have a secret plan, and we want to announce now is that we would like to make a fork of the semaphore chat, which leverage the zero knowledge technology to make a secret chat room. Yeah, hope that will launch in maybe next month.
Next month.
Coming soon.
Coming soon. Thanks very much. So next up, I want to invite Vitalik to join us. Do you have presentations or any?
I do. I'm going to just figure out how exactly to do this. Okay, so I guess I click a Chrome tab, and then I click over here.
Exactly.
And then slide.
Voila.
Hold on. Function F5. No, what's? Oh, there it is. Okay, yeah, it works.
Here we go. Well, that's
okay,
perfect.
Oh, it's perfect. Okay.
Okay.
Great. So I guess what I wanted to kind of talk about is Ethereum infrastructure. And what I mean by Ethereum infrastructure is like things in the Ethereum network that need to exist for Ethereum to be useful the way that we want it to be useful, but that are not part of a consensus layer, right? So if you look at Ethereum today, Ethereum infrastructure tends to look just something like this, right? Like, so you have on the one side things that are more efficient, but that are more centralized and have weaker trust models. And this is kind of Infura and basically everything that looks like Infura. And then on the other side, you can just run your own node, and there is basically nothing in between, right? So there basically either you are talking to a server or you are processing the entire chain, and there are light nodes that let you process somewhat less than the chain, but light nodes are still not very efficient, right? So the problems that we have with light nodes, like one is that the incentive model is not very proven. And what I mean by this is just like the incentive model for there to be servers that serve information to light nodes. And so we've had lots of these periods in history where there just aren't enough servers and it's fairly hard to connect with a light client. so they can be unreliable sometimes. Reading history and kind of scanning through logs and scanning through receipts and a lot of other things are often too slow. And the light nodes are still kind of too expensive, right? This shouldn't say light client. This should actually say why isn't every wallet running a light client, right? And actually, if after the presentation, actually, and I wanted to ask Chang-Wu a question, which is like, has IM token considered using a light nodes and a light client, and if not, like what, or if it has, like what it sees the challenges are. But I guess, I mean, to start off, we'll just kind of go through the presentation. I'm going to bring the ideas in first, right? So this is today, right? And today we kind of really lack infrastructure that's lighter than running your own node, but that's basically less centralized than Infura. In the future, Eth 2 is going to have many shards, and there's going to be many rollups and many plasma chains, and users cannot be full nodes on all of them, right? So this kind of right side is not really going to exist. So there's going to be different kinds of light nodes, but those have to actually be built, and there are going to have to be a lot of other things that get created. So to start off, thinking about today, right? So first of all, we can think about plugging the infrastructure hole, right? So we can think about trying to make ways of accessing and interacting with the Ethereum chain, which is simpler than running your own node, but at the same time has better trust models. So one example of this is better light clients using proof of stake, right? So when Ethereum 2.0 comes along, and in phase 1, it's going to come with a light client committee feature. Right? And the way that the light client committee feature in phase 1 basically works is if you have a block header, then from the block header, you can make a Merkle path to a validator set. And then that here, like in the Merkle leaves, you have some public keys. Then for these you could use these public keys to verify signatures. And these signatures are going to be signing blocks that are like one day in the future, right? So if you have this block that you know is in the chain, then you can see like basically what did the validators in the light client committee over here sign, and you can use that to kind of discover the chain in the future, and you can keep on hopping forward. And so the idea is that we could have a light client protocol that is extremely light. It's something like 100 elliptic curve operations and like 10 kilobytes per day just to sync with the chain. And then like, you only need a few signatures every time you want to check a block. Right? So if we have better light client protocols, then kind of this, I consider this to be a kind of one example of infrastructure. It gives nodes the ability to just stay synced with the chain and to learn about what the latest blocks in the chain are without having to either run a full node or trust Infura. So this is Eth 2 based. There's also this wonderful project called Incubes that exists today, and the way Incubes works is basically a crypto economic light client. So the idea is that in the Eth 1 chain, there's a contract, and you have people who deposited ETH into that contract, and they make signatures that attest to what the current block hashes are. And if they provide block hashes that are wrong, they can get slashed. So Incubes is this kind of really interesting project that tries to basically give you this kind of light client that's even lighter than a current light client, but that still has more security than a centralized system because you have these security deposits in a contract. Now, interactive history scanning, right? So this is a different kind of problem, right? So Ethereum applications in general, a lot of the time, they just require accessing the current state, right? So they require accessing what is your balance, what is this particular variable in this particular contract, what is the result of making this particular static call to this particular contract. They require sending transactions, but there's also many applications that require history scanning. And so, for example, if you want Adapt to give you your transaction history, you need to scan for receipts. If you want to, like, say, use a system like a rollup, you might need to scan for receipts. There's a lot of the time you want to see if a particular transaction has been included on chain. And these things are hard if you do not personally store the entire history, right? So right now, phone nodes usually store the entire history, and this means they take up hundreds of gigabytes. But ideally, we want nodes to be able to store only the current state. And so I wrote up this post in Magicians basically advocating for a special purpose of light client design that allows you to, like, either Merkle proof or have kind of crypto economic claims that say, like, this is the set of all receipts that matches some particular topic. Right? So basically, you kind of bypass the current Bloom filter architecture and instead, like, just use this to kind of challenge response market and make the process of securely learning things about the history much more efficient. And there's a protocol called the Graph, which is kind of trying to do something like this right now. So that's interesting. And if people want to look more at it, they can. Relayers. This is another kind of infrastructure. This is a kind of infrastructure that exists today. So the problem here is that there are use cases where users cannot pay the fee themselves. One example of this is Tornado Cash, kind of privacy solutions, because if you want to privately move your coins from one address to another, you don't have any coins in the address that you're moving to, and so you have no money that's kind of already in your account to pay for the first transaction to bring the money into your account. And so the only thing you can do is to kind of move your money in from another account, but then that creates a link and that breaks your privacy. So Tornado Cash has this system of third-party relayers where a third party kind of fronts the transaction fee and they collect money to base from the withdrawal that you're making. And this is not a very efficient market, right? So here we see you have a relayer market that's adding about 10% on top of the network fee. And I remember when fees were lower, it was the premium was even higher than 10%. There's inefficiencies, like, for example, what if you send one of these withdrawals and then gas prices suddenly go up? So relayers are a market that exists today. It's not a perfect market. But then there's this question of, well, we have some EIP, I think it's 2938, that's trying to add base layer account abstraction so you can have smart contracts kind of pay fees at the base layer. And will this remove the need for these real layer markets? And if we don't have base layer account abstraction, then potentially, and this could be done at the rollup layer, right? So this is kind of actually potentially one kind of infrastructure that hopefully we might need less of in the future. I don't know, we'll see. Now, planning for the future. So in the future, if we are going to take this layer 2 centric path, which, as I've been mentioning recently, is the most realistic path to do some short-term scaling, then a lot of people are going to be using layer 2 protocols. There's a lot more data to deal with, and so we're going to need a lot more infrastructure. One example of this is static calls going into layer 2s. So if this is a presentation I made at the ENS workshop about a week ago, and the idea here is basically that if we want people to be able to register and manage ENS domains inside of layer 2s, then we need ways to resolve domains that only exist inside of layer 2s, right? If, like, say, I want to send you some ETH and you have some .eth, .something.eth ENS address that exists only inside of a layer 2, then I need to be able to figure out, well, what actual address does that domain resolve to without doing any kind of layer 1 lookups because, well, it's not on layer 1. So here I suggested basically a protocol that allows you to do static calls, so that allows you to kind of gather information from the a layer 2 protocol, and that has some kind of crypto economic mechanisms in it. So, you know, if you want to kind of look this up, and I'm sure if you just look up like Vitalik, something like ENS workshop, I might have tweeted about this a few days ago. So this is one example of infrastructure that we are going to need, right? Like basically, if the bulk of Ethereum activity is going to move from layer 1 to layer 2, then all of these things that we have for layer 1, we're just going to have to replicate for layer 2. And hopefully we can have them with much more security than the current kind of relatively centralized approaches that we use. Watching layer 2s, right? So this basically means like watching to verify that there isn't fraud going on, publishing fraud proofs, checking that data is actually being published in a plasma chain. If it's unavailable, withdrawing. Checking that data is available in a channel system. If the data is unavailable, withdrawing. Challenging other people's withdrawals. So there's going to be a lot of this kind of watchtower infrastructure that needs to be deployed. And here the challenge is just making sure there's a really strong guarantee that at least one of these things is running at any time. So this is something that basically just someone needs to do it, and it kind of just needs to exist. Cross-shard and cross-rollup exchange. So if we are going to have applications that live in different shards, or that live in different rollups, or that some live in plasma, some live in rollups, some live in the base chain, it needs to be really fast to move coins from one to the other. Cross kind of shard or cross some like rollup exchange, it's a problem that we've thought about for a long time. And here's a screenshot from I think it's 2016, where I have this kind of standard Merkle proof back and forth protocol. But this needs to be made as efficient as possible, and the question is, and of how fast and how cheap can we make it? So I guess keep in mind that these are all things that we are going to need. So we're going to need infrastructure for learning about history without either personally storing all the history or without trusting a centralized server. A lot of these protocols depend on intermediaries, and so you need some protocol for discovering intermediaries, ideally some kind of reputation, so you discover kind of honest ones instead of dishonest ones, or ones that are just trying to waste your time. We're going to need a lot more peer-to-peer networking, so kind of a lot of these designs, especially the fraud-proof based designs, they require some kind of challenge network where if you receive a message, you need to rebroadcast it, and there need to be challengers. And if a challenger sees that someone submitted something wrong, they could publish a message to chain to challenge it and take away a security deposit. So there's a lot of kind of these different pieces in the ecosystem that I think, and there's a lot of room for people to be working on. Mm-hmm. Okay.
Hello. Yeah.
Yay.
Thanks very much. Vitalik, you mentioned something about ARM token.
Yes. No, actually, Chang-Wu, I wanted to ask does ARM token have ideas about using light clients or something more better than talking to a server? Or if not, why not?
I'm not sure, but for my client, when I working at Armies, we are thinking for the solution for the light client. So we are looking for accumulator, but just like flight client. But I don't really know the progress so far. So
right.
Yeah.
So that makes sense. I think this is something that I think we should stay in touch more on. I mean, right now, I think mobile wallets have been doing really well this year, right? I mean, in addition to ARM token, Status has been making a huge amount of progress, but at the same time, we want these wallets to have as strong security guarantees as possible. And so, if there's things that the base layer can do, or that the infrastructure that we can build to make this easier, then we should figure out how to do it.
Yeah.
So I wanted to ask if Hsiao-Wei or Ping or Jeff have any thoughts or comments that you would like to. Maybe Ping, yeah.
Okay, one question. I wonder the progress of the VDF, and would there be a remedy of that the proof of stake is, however, subjective?
I mean, VDF progress is definitely continuing. I think it's we're in the process of kind of auditing and finalizing the details of the code that'll be used to run the ceremony, is my understanding. But then Justin is the one who's kind of leading the project, so he kind of knows much more about it. And can Vdfs be used to improve the security against the long-range attacks? To some extent, right? Like what VDFs force you to do is they basically force you to, like, if you're attacking, they force you to start the attack at the time that the attack, at the time that you're branching off from the original chain, right? So like attacks that say like buy up some old keys and then attack immediately, that's going to become harder because like you'd have to do some VDF solutions first. So I mean, it's not perfect, right? Because if you buy up some old keys, you could still wait half a year, and then like VDFs do need to have a kind of some margin for error. And so if you can compute it twice as fast, then like you could still do an attack. So and also like if you do start your attack kind of in real time, you could still do it. So I guess it's not going to make long range attacks impossible, but it can definitely improve them by adding a fairly significant kind of speed bump to actually doing an attack.
How about preserving each one miner?
How about preserving each one mine? Like, I don't think VDFs will do that much to preserve each one miners because VDFs will like you only really need a few computers to be computing the VDF. Like I think realistically, like if he like the work that the kind of mining that I think crypto will see 5 years from now is going to be generating ZK Snark and ZK Snark proofs.
Interesting.
So one question.
Yeah.
How do you see the interoperability between different roll-up solutions?
And so I see there being two major families of roll-up solutions. One is a kind of roll-ups that try to focus on simple payments and maybe one or two other applications like a DEX, and those are the ZK roll-ups. And then the second family is roll-ups that basically try to pretend to be Ethereum, right? And that includes like what Optimism is doing. It includes sort of what Arbitrum is doing. Now, if like those, like they're going to pretend to be Ethereum, but kind of plus adding extra features if they can, right? So they might add parallelizability and like other things that you can't have on mainnet. But I think within the first, like between the first and the second category, and within the first category, the only kind of interoperability that you can have is just like ease of moving coins around, right? And like I think ease of moving coins around is the sort of thing that there is high demand for, and it is something that we should start building very soon. So it is, but like it's a very kind of defined problem, right? So I guess if you can do it, you can do it. The second kind of problem is can you like more sophisticated interoperability between different rollups? Like, could you have smart contracts like migrate from one rollup to another? I think I mean, the challenge there, of course, is that you can't necessarily prove that another rollup is running the exact same protocol as the current one, I mean, unless it's like an exact clone or something like that, in which case like maybe you could. So the challenge is basically figuring out like what are the kind of permissions that you would need. And then there's another kind of interoperability would be a kind of smart contract being able to make asynchronous calls to other rollups, which I mean, for that, I think the challenge is that like the different rollups are going to have a kind of different risks of being reverted because like there's someone published a bad block. And so you're not going to be able to have like airtight interoperability with a time of less than 1 week, but you could have a crypto economic interoperability that says like, either this call happens or someone gets compensated. And I think, approaches like that are interesting and, we should look into them more.
So a few more questions from Hsiao-Wei and Jeff. So I'm going to let Hsiao-Wei go first.
So my question is that is that what do you think the role of stateless client will be in your infrastructure graph like that?
Again, stateless clients are a type of client, but they do require infrastructure in the sense that they require kind of nodes to serve them, right? Because like stateless clients are not going to be able to serve other people because they don't have much state, but they're going to require other nodes to kind of feed them blocks with witnesses. So we would have to actually come up with that kind of network. And I know Piper has been doing a lot of good thinking and work around that. So I hope that goes well. I guess, and in terms of what role they'll play, I guess the hope is that if you have a node that or if you a stateless client is just a kind of node that you can run, and it could be a way for node operators to have a lower cost.
Jeff from ENS.
Hi, Vitalik.
Yes, hello.
My questions are related to the cross shard, cross roll up, making them as cheap as possible. I was just wondering, like, what kind of strategies do we have to do cross shard and cross roll up transactions? And actually, is cross shard and cross roll up, are the strategies similar, or are they slightly different? Like, I was just trying to, off the top of my head, I was thinking, if I run a roll up chain, I might be competing with a lot of roll-ups. Like, what kind of incentives do I have to even do a cross roll-up transaction? Maybe I want people to just be on my roll-up and try and compete. With Ethereum Shards, obviously, if the Ethereum development team is doing that, it's a bit more easy. I was wondering if the strategies are similar.
Yeah, so I mean, Shards and roll-ups are very similar, basically because, like, the name that I use for kind of this category of things, I call it a domain. Like, a domain is a kind of collection, like an address space where you can do synchronous transactions between objects within the domain, but you can only do asynchronous transactions between things in that domain and things in another domain. And so shards follow this pattern, right? Like, a shard is a domain, but then cross-shard transactions are in a cross-domain, so they're only asynchronous. And roll-ups have basically the same property. Well, I mean, with rollups, there are more options in terms of doing synchronous cross rollup things, because rollups are tied to specific shards, and so rollups can move around which shards they're on, and potentially rollups could kind of decide to be on the same shard temporarily, which, like, within that slot lets you do operations between those two rollups, maybe. But in general, the simplest techniques are going to be very similar because they are going to be dependent on, like, some kind of async mechanism.
Cool. Just a follow-up question, like, what kind of strategies are we putting in to make them as cheap as possible, like elaborating on the slide you had?
So the simplest, like, basically, what we're looking for is some kind of a cross-chain decentralized exchange, basically. Right, and I mean, cross-chain decentralized exchanging is, like, not the easiest thing, right? Because it does depend on online intermediaries and so forth. I guess and there are, like, theoretically, we've known how to do this sort of stuff, and we've known the different ways of doing it for years. The problem is that we haven't really had anyone kind of sit down and build a complete solution. And then I'm definitely, like, if you're kind of interested in Ethereum hacking, then I definitely encourage someone to just sort of sit down and work on trying to build a complete solution. Like, it's even today, like, can you do a kind of a quick two-way exchange between, like, say, the Optimism rollup and like a ZK Sync or Loopring or something, or even the Ethereum base chain. Just trying to make that kind of as fast as possible, ideally in one slot. Yeah.
Okay, thanks.
I'm going to invite one last question from CC Liang, because he's been doing a ton of work, and I wonder if you have any questions you want to ask anyone on the panel. Just tell us, like, first of all, tell us what you've been doing.
I know you were busy in setting up the entire live stream broadcast, and I really appreciate that.
Thank you.
Talk to your microphone. Yeah.
I've been doing optimistic rollups recently with Vdfs, and the project name is the Harbor project. And yeah, we hope to achieve like 2,000 to 3,000 transactions per second with BLS signatures. Yeah. So that's what we're working on. We are also actively working with other rollup teams, and to help them to integrate it what we have now.
Yeah. So CC is going to have his speech next week, Thursday, same time. So this hour, with Barnaby, the French researcher in Singapore right now, I believe, working with the Ethereum Foundation. So Barnaby is going to talk about EIP 1559.
Yeah.
So I encourage everyone to sign up to using the event page on meetup.com, and I hope everyone can join and participate this very important conversation. Yeah.
Do we still have time for 2 questions?
So we've got a few questions. Is it okay if we have like a few minutes?
Like 2 questions.
Okay. All right. Go ahead.
One is how XDAI would help scalability, and yeah, this is.
And I guess XDAI is what we call a sidechain, right? So it's a network that doesn't have the benefit of being secured by the Ethereum network, whereas layer 2 is like rollups do. So I guess I definitely don't see things like XDAI as being an ideal long-term place for applications to live, but in the short term, and as a staging area until other forms of scaling mature, I think things like it are definitely going to be necessary and very valuable for a lot of applications.
Yeah, thank you. And I also want to add that Barry recently have a great research post on XDAI and point out some of the security trade-off of the XDAI. I'll show them later in the comment section. And the second question is, how would Eth 2 implementation affect layer 2 solutions? Would layer 2 be integrated directly for adding scalability, or will L2 solution have to be updated to be operate with Eth 2.0? I think the question might be how many adjustments?
Right. So I think the answer is not too many adjustments. So basically, what needs to happen, right, is that the layer 2 applications would need to use the Eth 2 chain or Eth 2 shards as a data source. And what this means is that instead of having a transaction that just directly contains kind of the entire batch of rollup data, you'll have a transaction that contains a Merkle branch that points to the Merkle root of a particular shard block. And so if you have that, then you basically, that proves that data has been published. And so that gives you the security guarantees that you need for a rollup. So you would need to kind of do that tweak, but it's not a very large one. And otherwise, the way that a rollup works is going to end up being very similar.
I have a stupid question. How do we do fraud proofs on the shard chain?
How do we fraud proofs? So fraud proofs of a rollup if the rollup data is in the shard chain, you mean, or what?
Yeah. For I suppose a coordinator submitted a valid proof on the shard chain.
Right. So the idea would be that execution would still be on the beacon chain, right? So what you would do is you would just republish the entire shard block into the beacon chain.
Yeah.
And this would be very expensive, obviously, right? But you could still do it because a fraud proof is exceptional, and if whenever there's a fraud proof, there's some security deposit that you can take, so you'll be rewarded for it. And so you publish that entire shard block into the beacon chain, then the contract will verify that the shard block you publish actually is the shard block that got Merkle proven, and then from that point on, you just do the same fraud proof that you would do before.
I see. So so they have the contract logic has to be implemented in the beacon node.
Yes.
I see.
Mhm.
Thank you very much.
Thanks very much, Vitalik, Chang-Wu,
Yay.
Hsiao-Wei, Tenping. I appreciate it. I hope you guys will, I hope we all stay in touch, and I hope we hang out at the East Global events that's currently happening. And I also look forward to meeting you next year, hopefully at DEF CON. Yeah, it's in August, right? I remember.
Yes.
Yes, perfect. So I appreciate it. Thanks very much, everyone.
No, thank you.
Thank you.
Bye-bye.
Bye.
Bye bye.
Bye bye.